Imagine if you could actually see how a system detects suspicious activity in real time. Not just theory, but a live working model. This project is developed as part of our SCIES work. Our team consists of Witness and Harsha, with additional support from our classmate Gurvinder. This project is based on the operating system's concept, user-friendly system call interface for enhanced security. Our objective was to design a system that not only handles system-level actions, but also improves security through monitoring and analysis. In most cases, system-level operations like system calls are invisible to users. We hear about security threats and intrusion detection systems, but we don't actually see how they work. So, the question we explored was, how can we make system activity and threat detection visible and understandable? To solve this, we built a web-based simulation of an intrusion detection system, or IDS. This system monitors simulated system calls, analyzes the behavior, assigns a risk score, and flags suspicious activity in real time. Whenever a program interacts with the operating system, it makes a request called a system call or sys call. In our system, these calls are simulated. Each action is evaluated, and based on its behavior, it is classified as safe or risky. That means allowed or denied. There is a guest user who is the P1 for the process 1. For the second process ID given to the admin, who has all the root privileges. The third given to the malware agent. This is for the untrusted binary. And the fourth, it's the web server. As you can see, our other key feature is ACL permissions, access control list, with which it's associated with menu trivia. Our other key feature on this dashboard is the kernel pipeline. It has 4 stages. Init for the process lookup, authentication, permission gate, which is the ACL, and the system call dispatch within the execution stage, where the path to target is etc password. I will execute system call and let's see how it will be in the kernel pipeline and its status as well. Excellent. Here it is, our fast log. Process ID P1, the result is allowed, the system call is file read, the target is, this is because the permissions given within the access control list for the first process is having file read and file write. What if I choose to give it file delete? Wow, it only allows for the reading of the file and not deleting of the file. So let's go to our malware agent. As we all know, if we go for the admin, which is the second process, the root privileges, he or she has all the privileges. So the result will be allowed for all permissions within the access control list. Well, any failure within any stage of the kernel pipeline, the process ID won't go to execution, won't be dispatched the system call, so it is sent probe, and thereby the result is denied. So as we see, the system assigns a risk score based on behavior. This score is compared with a predefined threshold. If the score exceeds the threshold, it is flagged as threat. This is number 3. All events are recorded in detailed logs, as we can see. In the security metrics, we are having 6 total processes. 3 are allowed, 1 is blocked, and thereby the efficiency is 50%. The threshold acts as a decision boundary. A lower threshold makes the system more sensitive, detecting more events but increasing false alerts. A higher threshold makes it stricter, reducing noise but possibly missing subtle threats. This balance is essential in designing any intrusion detection system. On the screen, you see our threat monitoring dashboard that displays real-time system activity, alerts for suspicious behavior, risk levels of different events, and a continuous stream of logs. This makes internal system processes visible and easy to understand. Whereas another key feature of this system, detailed audit logging. Each event records timestamp, process ID, type of system call, whether it was allowed or denied, the reason for the decision, and the risk score. This allows complete traceability of system behavior. This project helps understand system-level operations visually, learn how intrusion detection systems work, and bridge the gap between theory and practical implementation. In summary, we transformed hidden system activities into a clear interactive experience. By combining system core simulation with IDS subconcepts, we've created a tool that is both educational and practical. Thank you for watching. Because in cybersecurity, what you can't see can be risky, so we made it visible.